joining in. Thanks, Kasam, for having me over here for this session. And I think it's time. Let's get started. So today we will be talking about 204, and this is mostly a certification preparation session. So what we'll do, we don't have enough time with us, but whatever we have, we'll try to put that in a very interesting manner. I have a case study with me, and I will be walking you through the case study, and I will be explaining the scenario. I will map it with your certification as well. That why should you do the case study, which I'll give you as a lab also if you want to do later on. If you do that, how much percentage of your certification will get cleared just by doing that? And it's going to be very interesting as well. So you will like it. So it's called as modern application. Like in today's world, we are not talking about those end-tier applications. We are talking about more cloud native microservices or maybe any data AI oriented applications where everything comes together. Modern app. So how do you create modern app and how do you basically design that or what thoughts are there when you make that? So we have a customer scenario. We'll go through that scenario and then we'll try to understand the requirements plus the solution plus how does it help us out in clearing the 204 certifications. Okay, so I have prepared a little bit of slide deck. So let me please walk through that. Before that, my name is Shivam Sharma. I will just quickly. This is my LinkedIn profile. You can go and find me over there. I'll put this in the chat window. So I can see the introductions in the chat. Thanks for it. I work in AWS. I also have 104 AZ-900. I joining in from Michigan, working on SQL database, but new to Azure, not using it right now. Sorry. So this is my name is Shivam Sharma. Basically, I'm working in Microsoft Azure since 2011 now, 11 or 12 like that, and since the old Azure portal. And I also work in GCP. I have somewhat understanding of AWS as well. My most experience lies in Azure. And now I have ended up working on multiple services in Azure, like in infrastructure, in designing, architecting, development on Azure, data platform, AI. It's been a long journey on the cloud. So the cloud sort of is like that one single, you can say, shop for all your requirements. So similarly, I also got the opportunity of working on multiple platforms. So my LinkedIn profile is there in the chat window. In case you want to join me over there, you can connect with me. As such, in case you have some questions later on, feel free to ask. So what we are doing today, let me just walk you through what is this developer certification? What do you have? What do you expect? And so on and so forth. Then we'll continue with the case study. I'll walk you through the requirement and the solution of it. And maybe I'll give you the workshop to do as a maybe as a homework where you can deploy it as well. Okay, so now check this out. Now, this certification, the AZ-204, so you have to clear one examination to get one certification. It's like one-to-one mapping over there. So the certification name is called as Azure Developer Associate. The examination which you have to take is called as 204, like that, right? Required examination. Sometimes in Azure to get one certification, you have to clear two examination. Like it happens in the architect track, like you have to clear 303, 304, then you become the architect on Azure. But in developer, because this is an associate level certification, so it's not that tough. And only one examination is what we are supposed to take, not two. Now, what I personally like whenever I do any certification, what I like to read from their documentation. Like documentation is the most updated thing, which they provide. And then the second thing is hands-on. If you do hands-on, you will be able to clear it, because it's more like you 100 times you read something or versus you do the hands-on once and then you are able to understand the concept way better. So what personally what if you ask me that do this certification, then what do? I basically go through the details as such. So the details outlines are over here. I'll give you these links in the chat. I'm giving the landing page in the chat. Recording is anyways with you. So this is the landing page in the chat from where you follow it through. Now the details are available on this link over here. And if you want to do the hands-on part, what Microsoft did, they created MS Learn. So you see these links are there at the bottom of the page, like create serverless application, connect your services, store data, deploy the websites or in virtual machines, manage resources in Azure. So this is this redirection happened to MS Learn. So MS Learn, I'm pretty sure if you work in Azure, you are aware of MS Learn. If not, if I just click on this browse, let's say browse, there are around 3000 tutorials are there. Some of the tutorials will only have theory over there, will not have any hands-on, but some of them will have hands-on, and some of the tutorial even give you the environment to do the hands-on in. For example, if you don't have Azure subscription, then how do you do it? So for example, if I just show it to you, let's say one of them, which I recently used, so I sort of remember it. Check this out. So if you do this Cosmos DB lab over here, they will give you the sandbox environment. See, activate your sandbox. So 10 sandbox per day can be activated. Just give me 1 second. So I just wanted to sip some water. Okay. So this is that sandbox environment, which you can activate from here, and you can do the hands-on as such. So this is this MS Learn is somewhere where you should be doing your you can say where you can have a multiple tutorials are there which are very well written, which are very, you can say, 5-star type of tutorials, and which you should will help you in doing the certification. Now you can come to this page and you can just say I'm looking for the developer track. So you go here and you click on developer, and then it sort of you have these 999 tutorials are there for just for the developer track. It covers from the fundamentals to the end of it. And then we can also do a type of learning path, like I am looking for I'm not looking for individual tutorial. I am looking for a scenario as such. So then see, there's 2 hours of scenario, another 2 hours of scenario, 2.41 minutes of scenario, 1.441 like that, 1 hour, 3 hours of scenarios like that, 8 hours of scenario. And this is gonna be a long one, but you can definitely do that. So this is where you should be, you can say, this is that structured content when you're doing self-learning. See, best learning is self-learning, so you can definitely go there and you can learn on your own as well. But the main thing is you have to do hands-on. Now, when you go for the certification, there is also some official content given by Microsoft. Now, Microsoft has gone sort of open now. So what they have done, they have released everything on GitHub. So if you, when you are trying, so for example, if you go to any institute and or as such, or you come to me for the training as such, even what I do, I basically we in the training, we do the official labs. So official labs are listed on this GitHub page. I'm giving you this GitHub page in the chat window. Now, if you're doing self-learning, you basically go to this page. There are 12 labs over there. Tutorials are there. These tutorials are not easy. Some of them might be easy. Some of them are pretty difficult. So you'll used to it, get used to it, like polyglot data and all that. It's pretty long. So what you can do is these are those 12 labs given by Microsoft officially. The previous MS Learn was not directed only to the certification. It was like if anyone wants to be a developer in Azure, then what all should they know? But these 12 labs are just directed to the 204 certification, so you can clear the developer track as such, right? So I recommend that those who are planning of getting certified, this is what you have to hit first. You click on them and you deploy them in the portal. Now you need subscription to do it. If you have the subscription, amazing. If you don't have the subscription, you go for free trial, right? Before anyone asks, you go for this free trial subscription. Just look up, just Google for it. That's the free trial. If you have already used your credit card, get some credit card from your family members. This subscription is free of cost, but you have to put some credit card in the starting to be able to get the certification, get the subscription in the starting itself. So because of that, if you have already used your credit card, I used mine, I think in 2014. So then I sort of use other people's. If I need free accounts, I use other people's credit cards over there. Okay, so, and just the good thing is, whenever the word comes credit card, it's very risky, right? What happens if we forget to delete the resources and it's charged in the credit card? Nothing like that will happen. When the subscription will expire, they will give us $200 as such. When the $200 will expire, the account will automatically block. They will not charge you a dime from your credit card. It's just for authentication purpose, whether you are you or you are some sort of bot attacking, you can say attacking the Azure platform. So that's where you have to from where you get the subscription. These are the labs which I have given over here, which you will follow after this session to be able to get certified, right? These two things are there in the chat window. Keep a note of them. Now, what we will do, I'll walk you through the outline as such, and then I will walk you through the case study which I have, and then scenario. We will design the scenario today, right? And with that scenario, we will pick up the topics from this, you can say, from the tutorial, from the outline of Microsoft's 204 certification, and we will try to learn something in the session. That's what we are planning. Just make sure your cameras don't get enabled without, yeah, it got enabled. Okay, so web app is something which is one of the major section. Before I go in this, see, they have given another page here. So in this page, what happens? They give the percentage, like 25 to 30% will be compute solutions, Azure compute solutions, right? When you talk about Azure compute solutions, if you I'll just give you one very important page which I generally use personally also when I have to architect solutions, not this one. So in the architecture center, yeah, I think this is the one. So see, this page is going in the chat. This is basically the design tree, or you can say the DAG diagram over here. Now, if you know these services, you are good, right? What is Azure Virtual Machine, Batch, App Services, Function, Container Instances, Service Fabric, AKS, you're good. If you know this, then the first part is good. Like this part is pretty well covered. You know more than what they will ask in that particular 25 to 30% of the certification. If you don't know this, this is, you can say you have to cover that part. There is, right, and then you basically will be good enough to hit that 25%. When to use what, if you, right, that's on this page, like which technology should you choose in which scenario? Why should I do this? That why is on this page. It's in the chat window. So 25% is basically compute solutions. In that, you have to talk about ACR, you have to talk about ACI, we have to talk about images, ARM templates, and so on and so forth. Web app, Azure functions are there. 15 to 20% will be storage solutions. Right. So this is where Cosmos database comes into picture. Cosmos DB is pretty interesting. That's one of the most interesting solution in the clouds, in any of the clouds today. The global distributed database, which is providing the 5 type of consistencies, plus it provides concurrency, plus it provides multimodal design. Like this is a semi-structured database, one database which is equal to Cassandra, one database which is equal to MongoDB, one database which is equal to SQL. You can say not really relational. This is non-relational, but it provides the same APIs. So Cosmos DB is something, if you are new to Azure, I recommend hit Cosmos DB first. This is one of the interesting solutions. You will like this more than the other solutions. So start your things from something which is way interesting, right? So start from this and learn it up. Like what is Cosmos DB, details of it, why do we have it, why is so important, what is the homing APIs over there, and so on and so forth. A little bit of Cosmos DB we will discuss today in the case study. Blobs are the old blobs, go through it. The object storage, go through it. Then security is something which is very important in today's world. Without so it's when we design solution, it's security first. It's security is not implemented afterwards. It's from the day number 1 we implement security. Everything has to be secure. Multiple layers of security, multiple solutions in Azure, network, perimeter, application, data. When it's more like an onion, right? So security is more like an onion. If the more the number of layers you have, more your secure environment is. So it's harder. There is a concept called as cyber kill chain. So it's the cyber kill chain becomes bigger, and the ability of the solutions in Azure to be able to detect when somebody attacks also becomes very, you can say, more probable when you have a multiple layers of security. So Azure AD is one of the core identity management service like IAM, where all the username and passwords are kept. But that's the easy way to describe Azure AD, username and passwords, but it does many more things. So this is Azure AD is definitely has to be used over there. What is shared access signature? Identity platform, securing the cloud. What is key vault? This word you will see, it doesn't matter which company you work in. If you're properly architecting your solutions, key vault will be there. Without Key Vault, it doesn't work out, right? Your application want to talk to database, your big data cluster wants to talk to the database, your the API gateway needs one SSL certificate to be binded to it. Everything will be there inside the Key Vault, and then then we bind all of that. So Key Vault is not very important from the you can say from the certifications point of view, but Key Vault is very is important from your practical productions point of view. It will be there, right? So okay, troubleshooting and optimization. Optimization is we all want to save money, right? We all don't want that things are running. We have over provision resources, and resources are basically you are paying for something which you are not using. So try to use serverless, try to reduce the resources, scale up only, and if you have provisioned the resources, you make sure you are using the resources, right? Secondly, how can you make things faster? If you have, so there is a concept called as scalable web application. So I'll give you the architecture of it. This is something if you web application like that in Azure platform. So over here, so this page is pretty important. If you understand this single architecture and all the components which are there, it will, you can say, a very big percentage of the certification also gets covered, and a big percentage of the practical, modern, scalable, responsive applications in Azure also gets covered with that. So if you see, they have Azure DNS over here for the name resolution. They have Active Directory for the authentication purpose. Azure front door is called as application delivery network. It accelerates your application. The traffic reaches the application way faster. CDN is the static content delivery, like the reverse of it when you're pushing the videos and images and all that back. Blob is the cheaper blob storage. Web app is a web app PaaS solution. Queues will decouple the web app layer. This worker role with this web role with the worker role over there. This queue will decouple. So how many types of queues are there in Azure? So what you have to go through is that how many types of queues are there in Azure? When should we go for which one? We have service bus queues, we have storage account queues, we have service bus topics as such. So in which scenario, what has to be gone through? So what is Azure function? How do we use it? Is it so? This is serverless. So is serverless the in which scenario we do not use serverless? Serverless, everyone knows it's pretty cool and all that, but when should we not use it, right? So that you can find on this page. When should we not use it? And secondly, when you use serverless, the problem is serverless components, they scale very fast. They scale very quickly. They scale to number of instances. So when that high scalability happens, the practical problem is that the other backend services are unable to handle that scalability. If this layer scales up, my databases will not be able to handle that much of request which is coming. So I cannot let it be scaling to infinite as such. What I can do, there is no infinite, but practically you can say maybe 100, 200, 1000, 1500 instances, but that's a huge number, right? So what we do, we in serverless, we always put a upper limit. So in this Azure function, we have the host.json files are there. In those host files, we put the upper limit, like that when you are scaling, don't scale beyond this limit, because if you do that, my backend systems will not be able to handle that, and I will end up having more trouble than what I was trying to solve. Then what is this cache doing over here? There's a concept called as cache aside pattern. You can watch any of the previous. I remember there was one session on the design patterns on Azure. I think Kasam himself did that. So you can check out in that session what is cache aside pattern and how do you implement that with the databases. What is at the read time? What happens at the write time? What happens? So how is this making sure that the responses are coming way faster? Azure Redis cache. And secondly, when we should not use it. If you don't have frequently running queries, you don't use the cache because it will add that overhead latency and it will make things way slower than faster versus faster. So right. Now, relational databases, this is a relational database that is semi-structured, right? This is where you keep your structured data. This is semi-structured in nature. Cosmos DB is semi-structured, no SQL, semi-structured, no normalization, nothing like that. So, and global database. So when should we have this one? When should we have that one? What are the requirements when we should go for them? And what will this give me? What will that give me, right? in that sense. So, and how do you Azure search is just like the cherry on the you can say on the cake here. But this search in this diagram is just basically doing that scrolling over it's crawling over the data sources, creating indexes over there, over which the functions can further iterate. So this one architecture is very useful. The one thing which is missing from this architecture is the high availability. Like these are single point of failures, right? This is single point of failure, that single point of failure. So this is not high available. For high availability, you can look up for any other architecture over here where they have some sort of active uh, you can say active scenarios running or active passive scenario running, so you can further think it through. But that goes more in the architecture session. It's not making the high availability over there is not really the responsibility of developers. uh, Making sure that's something the architecture, you can say the architect should do that. So but this is something, if you go through this, details of it are on this page, and you learn why should we do it and implement. uh, if you want to deploy this, all of this is available in the labs which I gave, the 12 labs from Microsoft. They have this in bits and pieces, like they implement CDN somewhere, they implement queues somewhere, functions are there, cache is there, SQL is there, and so on and so forth. So uh, all right, so this is where that cache is there, caching patterns which are used. Should I do expiration, eviction, or encryption, and so on and so forth. So this is around 15 to 20% of your certification. Monitoring and logging. The application insights is there since ever. I don't remember when it got started, but I am seeing this since so many years now. It's there, it was there in Azure since the very starting itself. This is one of the oldest service. uh, the new service is Azure Monitor when they combined everything together. But application insights is something which you have to use for the monitoring of application. Like when you open the page, what was the turnaround time? What error came? Which error came? 404. How many times 500 came? How many times maybe 200 happened? From where the person opened? If when the application was talking to the queue, what was the latency between that? Like was it is it available in let's say the average latency was 9 millisecond. Is it 9 millisecond or is it more or is it less? So all these details will be there. Is what application insights can get me from the application. So this is the one of the major monitoring service which developers will be looking at. The dashboard of application insight is something which you keep open, and then you just keep on looking at that it's when if something fails, this is the one which will tell us, and we will quickly go and fix that. So this is that service. Now, 15 to 20% will be third-party services. Like how do you connect and consume Azure? Like you have to APIs come into picture. So APIM is like APG type gateway. APIM is a very interesting solution. This is one of the good solutions where which doesn't have many downfalls. Like sometimes what happens, the solutions may be having some, okay, it doesn't support this. So Azure SQL PaaS doesn't support that. Or there are some limitation. Yesterday in one of my trainings, even there was another limitation of Azure SQL PaaS, which even I didn't notice, which was brought to me by the participant, that it doesn't do that. I was, yeah, it doesn't do that. So, but APIM is one of the services which is like other people try to copy this. Like let's make the gateways like APIM. So go through it. Event Hub, Event Grid. There are two things. Like event grid is used for reactive programming. Reaction happens, like when something happens, then based on that you should trigger another workflow, another process, or then something should carry on. So that reactive programming is event grid. The events are discrete, they are not continuous. When you ingest data on a this event hub is Kafka cluster. It's basically at the backend is having Kafka. There are 100 broker, 1,000 broker, 10,000 broker SKUs are available. So, but basically that's Apache Kafka at the backend. So it's an ingestion layer solution. It basically ingests data. It doesn't process or anything. Right, and then as we were discussing, what is service bus queue, storage account queue, and so on and so forth. So this page is where you have the outline with you in percentage. That's something which you have to keep in mind. Now, what I will do, I have this case study with me, see. So I don't want the session to be without discussions as such. So I have this case study with me, and this is the solution of that case study. which covers around 90% of the 204, and it goes beyond that. So it's good enough, right? So what we will do, we'll go through the case study. I'll explain the scenario which is happening, and then I'll walk you through this solution, like the various bits and pieces over there. How is this Cosmos DB doing what it is doing? What is this Azure function doing? What is Stream Analytics doing? What is this Postgres doing? Can we replace this with this SQL? What is AKS doing over there? What is this IoT Hub, Event Hub doing? And so on and so forth, right? So that is something which we will be discussing today, the solution of the scenario. So we will understand the scenario first, requirement of this customer, what do they want from us, and then we will look up the solution. Then I will give you the solution as a hands-on lab. Whenever you get time, do it. If you do it, uh, it's something which is very, you can say, you can learn a lot from that one single scenario, right? Now, before I start with this case study, if anyone has any question, feel free to put that in the chat window. Please use the chat as the medium to communicate. We'll take the questions in the end. I'll just open my whiteboard in the meantime. Any question which comes to mind? I kept some pictures opened. Okay. So what we are doing is today we are talking about modern app. Which I want as well. And let me just, yeah, okay. This we'll go to that design in few minutes. Check this first. Right. So what we do is so this customer is basically called as wide world importer. So there is a customer called as wide world importer, and this customer basically have seen it's called as CNC machines, computer controlled, you can say, machines as such. The exact term is, let me just quickly, is computer numerical control machines, right? So this customer which we are talking about is having these CNC machines. So the machines are computer controlled. That's the soft meaning of that. You guys may be knowing more about CNC than me. I just sort of am able to relate with this, that some these machines are there. Uh, uh, Computer controlled machines are there, and this customer is looking for one scenario as such. So the name of the company is Wide World Importers, and they have around 50. Let me just read how many. They have 5 factories with them. I'm reading the scenario from my secondary screen. 5 factories are there. From those 5 factories, the customer is having 900 different type of, you can say, machines are there. 10,000 sensors are there. And overall, they have around 50,000 sensors in all the 5 factories, in all the machines, which are sending some data to the cloud. So there are around 5 factories and around 50,000 overall sensors, which are sending the data, right? So here. So all these machines are sending us the data. See, whenever in today's world, data is pretty strong, right? Data is something which is very useful. So if your application is able to consume is AI oriented, or if it is data oriented, then you may be having that edge in the market versus your competitors. So now the preferred solution which we have for this company is what I was showing you earlier. But let's check out the requirement first. So 50,000 sensors are there, and the data is coming as a stream right now, right? 50,000 sensors as such, and streams are coming in. So the application is supposed to do multiple things, but the first problem this company has is that this stream has to be ingested. See, there is a stream coming in. The stream has to be ingested. So in Azure, whenever you talk about stream ingestion solutions, we have two things as such. We have IoT Hub. So there is one stream ingestion solution called as IoT Hub. So IoT hub like that. There is another one called as event hub like this, right? The rule of thumb is that whenever the streams are coming in from the IoT devices, you go for IoT hub as the name suggests. And whenever you have any application sending the data, like imagine Zomato apps were there, or some sort of Uber apps were there, and some events were coming from the Uber apps. People were trying to book the ride. They are saying my driver is not coming on time. I'm getting late. Whatever. So then we go for Event Hub, right? These are two PaaS solutions which are there in Azure platform, which ingest data. What are these? These are platform as a service solution, PaaS solutions, and they ingest data. Ingest data. Now, when the data is ingested, then only can you do something with it. If you are unable to ingest the data properly, then your solutions will not behave like that. So whenever you ingest data, you then comes the processing part. Like how do you process it? So in the modern applications, they might be using some ingestion layer solution as IoT Hub or Event Hub to get the data in. Then we start doing the processing over there. See, now we have a velocity problem. The data is coming from 50,000 machines at the same time, right? In some streams. What type of data might be there? Temperature data, vibration, maybe noise as such, maybe any human input happened. Maybe there was a pressure, there was some sort of gauge was there somewhere, some pressure was there which was used to move the pump around, the pressure got released, or anything as such is what we are thinking as the data which is coming in. So in the modern applications, which are somewhat data oriented, what this wide world importer want us to do is they want to have a very scalable consumer. So see, you might have heard about publisher subscriber, pub sub, right? Very interesting words, pub sub like that. So pub and the sub. So the publishers are these devices right now. The subscribers are there in Azure, right? And the broker is here. This is the broker. So the and we just talked about Azure function. Now what Azure function does, Azure function, if I just come back to your certification, Azure function is serverless in nature, right? Serverless is different from PaaS. In serverless, what happens? We have compute on demand. If you don't use it, you don't have to pay for it. So what I'm showing in the screen right now is that Azure function is scaling out as the data. If there is more data, more Azure functions are there. If data is, you can say, stream is there or not there, then they will scale in. So they will scale out and scale in based on the load as such. If you are not consuming them, you don't have to pay for it. This is not the case in platform as a service solution. In PaaS solutions, even if you don't consume it, let's say you allocated 14 GB RAM, but in that point in time you are using 11 GB RAM, then you are still paying for 14 GB RAM. You're not paying for 11 GB RAM. That doesn't happen in the Azure function. We have a consumption based plan. The downfall of consumption based plan is there is a concept called as cold start. Cold start may happen. So to avoid cold start, some of the companies, what do? They don't use the consumption based plan, which is supposed to be used, and they don't go for the serverless. They in Azure, we have a concept called as app service plan. They go for app service plan and they put the function inside app service plan, which doesn't make sense to me, but they do it. And it's no longer serverless, but yeah, they don't have the cold start problem. So cold start problem, it means that if something scales down to 0 instance and it starts next time, it will take 2-3 more seconds to start for the first time. That's called as cold start. So if your application is so sensitive, then cold start, you have to avoid cold start. Otherwise, cold start won't be a problem for most of the event driven applications as such. So whatever data is coming in, this function is the subscribers or the consumers which are scaling out and they are consuming the data right now, right? Now, as such, now what we are doing behind this over here, so I'm designing the solution on the way while explaining the requirement to you. Now, you were talking about the Cosmos DB, remember? We're just discussing about that. So now Cosmos database is a multimodal global database, meaning it will have multiple endpoints. You can select the endpoint. So imagine this dotted line is the namespace, and inside that you have 3 regions in Azure where you made the Cosmos DB. So over here, so this Cosmos DB is in East US, this one is in Southeast Asia, this Cosmos database is somewhere in South India, let's say over there, like this, and they all are syncing with each other. See, they all are syncing with each other in real time. Real time means practically whatever data size you have and all that is based on that Cosmos DB is syncing. So what is Cosmos database? Cosmos database is first of all semi-structured. There is no table there. Table concept is not there. We have key value pair. The Cosmos DB tables are key value pairs. So semi-structured, no SQL, uh, distributed database where multiple endpoints can be there. There is a concept called as request unit, which you have to understand in when you for your certification. So request unit is how you pay for the Cosmos DB. For example, in Cosmos DB, like if you write 1 KB per second, right? If you if you read 1 KB per second, this is equal to 1 RU. So 1 RU is the amount of resources required to read 1 KB per second. But what happens if I write 1 KB per second? Right, I don't read 1 KB per second, I write 1 KB per second, then the approximate ratio is 5 RUs. So it takes, the writes are 5 times more expensive than reads, which makes sense because writes are expensive than reads anyways. So Cosmos database is good for many scenarios where your schema is loose. So when should we go for this global distributed database? When my customers are globally distributed. Secondly, I don't know the schema. Schema may change on the way. Today you have 4 columns. Tomorrow you have 1 more entry coming in. Null values might be there. Loose schema is what you're looking for. These are some of the examples of when you go for semi-structured database. So when you will deploy the scenario I will give you, you will also use Cosmos DB as the database where the functions will be interacting with. So functions will talk to them over here, right? So functions are interacting with this Cosmos DB like this, like this over here. So if I just take you, you can say to the architecture back, so I don't have to manually make it, but now you will be able to follow it with me. So this wide world importer was getting those IoT sensor data is there, and basically from 50,000 devices, the data was coming in, and we have the IoT hub in the starting, and where the Azure function is the consumer behind that, and Cosmos DB was the database which was being used at the backend. Now, I will just go one step extra. When you work with this Cosmos DB, right? In Cosmos DB, we have 2 things inside that. We have the OLTP part as well, and we have the OLAP as well. So OLAP are the systems which are running the business. OLTP is the systems which are running the business. OLAP are the systems which are analyzing the business. So Cosmos DB is so interesting because it runs your business at the same time you can do analysis on the business. So this is something which all the companies you can say are looking for, and the short form is called as HTAP, hybrid transactional and analytical processing systems, like that. So Cosmos database has multiple use cases. So what this wild word importer is doing, they want that in the end of the day, they are looking for that mobile application, or they are looking for that web application, which is where if something goes wrong, that what goes wrong should be shown, or the floor managers, those who are in the factory right now near the CNC machines, they should be able to have a mobile app or a web app, and they should get notification that this failed, the device is going to fail, go and repair it or stop it or do something with it before it totally crash down. So they want that web app to be there. So this is the Azure web app. But this wide world importer company do not want to go for the native, you can say, any other old school architectures. They are looking for, they literally have a requirement of microservices. They are looking for that microservice architecture as such. So this web app at the backend, this interface should be interacting with multiple microservices as such. So how do you run web apps? So this is one of your certification questions over here. There are multiple pricing plans. Like if this is Azure website, so let's say this is Azure website. Now it runs in a wrapper, which is called as the app service plan. So app service plan. Now this wrapper which you have is having multiple SKU. Remember one thing from this session, that they 100% will ask you one question, that if you are running one web application in production, what is the minimum app service plan which you should have? Answer is standard. you should have a standard plan to be able to have something running as a PaaS solution in a web app in Azure in production, standard plan. Apart from standard plan in production, we also have isolated. Isolated is when the VNet integration happens. We also have plans which is called as premium plan. So this will have like there is a concept called a standard plan over there. Standard. Then we have the premium and the isolated like this. So like this, and there are some non-production plan below it. But the minimum production plan is standard. I don't know why, but they asked this question. They're asking this question since very starting. And I remember this certification was called as 532. Many years back, it was called as 532. So even that I answered that question. Then I got recertified in 532. Then the same question came again. Then 204. Then the same question came again. It's something which they like. So standard is a minimum plan which you should go for. So okay. Now, if you want to run your microservices in the cloud platform, there are multiple methods by which we can do it. One of the, you can say, go-to method will be using AKS. So Azure Kubernetes Services. Let me see if I can pull one picture of it. Okay. So, okay. So this is that Kubernetes services over here. Now, okay. So this is slightly where we are going little beyond your certification. AKS, so this is the icon of AKS, Azure Kubernetes Services. Now AKS is the go-to location where you will be running your microservices. You will containerize your microservices and you will run them inside the Kubernetes services in Azure platform. Now, when you deploy something in AKS, there is a ACR. There is a repository where you have to put the image. So imagine that this is a developer. So developer wants to develop the microservices which are running in Azure Kubernetes services. So the images containing the microservices needs to be stored somewhere. We need some repository for that. So in Azure, we have a concept called as Azure Container Registry. So let's say Azure Container Registry, ACR. Apart from ACR, you can use Docker Hub and all that, but use ACR because you're anyways doing it in Azure. So what are we thinking of? We are doing Docker push over there. So let's say this is Docker push as such, and things are going inside ACR like that. So this is your microservice and some versions are there, images are there, which is right now stored in this ACR. Then what do we do? From this ACR, we do the deployment in the AKS. So it deploys in Kubernetes like that. So microservices, the images will be stored. And what is this over here? There's a Docker image, right? So that two boxes which we have are Docker images as such. What is there inside the Docker image? Literally the application code, dependency and all that is there inside it. So ACR is part of your certification. You have to understand how to interact with ACR. You have to understand how to push into ACR, how to use ACR to be able to pull the image from it and then do the deployments. Now, in your certification, you don't have much. There is not much on AKS. You should just know it exists in the world. It's very useful. If you know it exists in the world and you deploy it, you are able to work with it, then that is something which will get you the job. When you get certified, you go and you want to get the job, they will ask questions on AKS. No one is going to ask you questions on anything else. They will say, what is Kubernetes? Now you are a developer in Azure. You are a developer in Azure. What is Kubernetes? Do you know how to work with it? So if you know how to work with it, then only your 204 certification will end up giving you some ROI of the time you are investing. Otherwise, no, not really. So learn this. Go ahead and you have to understand how to work with it. Second thing is we have another smaller brother of Kubernetes called as Azure Container Instances. So if when the customers do not have the microservice requirement, they are saying we are not looking for the orchestration, we are not looking for that massive amount of you can say networking and everything to be done, we go for ACI. So ACI is the you can say literally like single instance. So if let's say if I have one microservice, what I can do, I literally one microservice doesn't make sense, but let's say you want to say I want to run one container, then what should I do? You want to run your one container. deploy this ACI instance, give it some GB RAM. Let's say it is having 1 GB RAM, and maybe it is having 2 CPU core, right? And this is your application code here, dependencies inside it, and then which is running inside the ACI. So ACI is when we don't have that microservice requirement, when we don't have that Kubernetes requirement, when we don't need the orchestration, then we go for this. So for your certification, these are very important. For your interviews, Kubernetes is one of the most important thing which you should be able to work with in Azure platform, AKS. People will be asking questions on this. World is going crazy on Kubernetes. A lot of them don't even have the requirement, but they still want AKS to be there in the environment. So they are forcefully putting it there. So anyways, you have to work with it. So learn it. Now, what we are doing, this wide world importers is also looking for a little bit of the modern part. Like when you talk about modern application, the meaning is that your application should be able to interact with the AI services in Azure, should be able to interact with the data platform services in Azure, and uh, should be able to combine everything together under one umbrella as such. So that modern part is that you can say is the data oriented part. Now, whenever you have the data oriented part, analysis comes into picture. You have to analyze your data in real time. So if so, let's see over here. Imagine that you can say imagine that this that the data coming from this CNC machine over there. Uh, there is a temperature sensor over there, right? And the temperature sensor gets triggered 3 times in that 1 minute, 3 times, or 4 times, or 5 times. That it is beyond critical limit. So what we want is that if the temperature is going beyond the critical limit, we should be able to find that in real time and should be able to you can say work through it. So we should be able to stop the machine. We should be able to notify the people on the floor over there saying that this machine is going to burst. Please go and turn it off, right? So what do we want? We want analysis to be done in real time. So at times what you have to deploy is what you will end up working with will be some sort of uh, you can say streaming solutions as such. You have to write some piece of code for to be able to do stream analysis. So whatever data you are getting from the ingestion layer, I'll just make a box there. So it doesn't matter which you are using. Maybe you're using IoT Hub, maybe you're using Event Hub based on your requirement. Let's say these two. But at the end of the day, we are basically, you can say, doing some analysis on it. So the stream which is coming over there, we have this service in you can say in Azure called as Stream Analytics. So here, see, this is called as Azure Stream Analytics. Now, Stream Analytics is a very interesting type of solution where you can run JavaScript functions, you can run SQL functions over there in your modern application to be able to, you can say, work with it. So this is where we have those TSQL queries. So TSQL and something like this. So whenever you're working with the streaming data, there is a concept which is called as like windowing functions. Like whenever you develop anything for any solution like Stream Analytics, you have to work with windowing functions. Windowing functions means like the data was coming in real time, and then how do I run my queries on top of it? How do I run my JavaScript functions on top of it? So let's say over here, and then outputs is going on. So this is where we are doing the analysis. Let's say the analysis over there. So when you develop anything which runs on stream of data, let's say one day your company asks you that okay, you have to develop one function with some maybe in a Python or maybe with TSQL, maybe with JavaScript, maybe with anything else, but it should work on the stream of data. We are looking for doing the analysis in Azure platform. Then how do you do it? I'll just give you one example of it. So we have examples such as tumbling window. See, tumbling window like that. So these are standard concepts in the world over here. So what tumbling window does, for example, I have, let's say, different, this is a timeline which I'm trying to create. Let's say this is timeline is second based. So your data was coming from the IoT sensors right now, or they were coming from the customers. The data might be coming from tweets also. So this is the data points here, right? Like this. So imagine you have a window function. So this window size is 10 seconds, right? 10-second window size. So data is continuously coming. You have a window size. That window, whatever fits in the window is on top of that, you run the query. So the first query executes on this. The second query executes maybe when the data goes, and this is, let's say data came between 10 to 20 second, and this is my 10-second window over here, right? Like this. So then the query executes. So the practical problem you will face when you are developing something for stream solution is that data is continuously coming. So you have to hold the data in one location for some time. Then you run the query on top of it. Then you get the output. So we have options such as tumbling window where overlap doesn't happen. The window keep on moving up. The data keep on coming up, and we keep on running the queries, or and we enrich these queries with JavaScript functions. Second thing is, like, you may have some scenarios where you want overlap to happen. So overlap means like you have a hopping window. So imagine something like this. So uh, over here, let's say 0, maybe 10, 20, 30. You're saying that we are not looking for non-overlapping data. It's possible that some of the data is overlapping as well. So we have hopping windows. See, windows over here. So in hopping windows, what happens? Like, imagine there's a 10-second window, right? Like this. So now you are saying that hop size is 5 second, window size is 10 second. Window size is going to be 10 seconds, right? So it's going to overlap. So in hopping window, see what happened? The hop size was 5 second. So the window, the data which was in the previous window is also there in the next window, right? It is overlapping. So this is when you are saying find me the counts of the tweet every, you can say of last 10 second, every 5 second. So hops are going on of 5 second. If the hop size become equal to window size, hopping window becomes tumbling window. So whenever in modern applications you have to work with stream data, then these type of questions will be there. Apart from these two, we have many more type of session windows as well, which maybe in another session one day we'll cover. So data comes in, you write your functions in some sort of tumbling window manner, or you write your functions in some sort of hopping window manner, and then that is doing the analysis for you. So whatever analysis you do, you store it. So here you might be having some relational databases. So in your certification, you have to learn about Azure SQL. It's part of your certification. Cosmos DB is also there. The Azure SQL is basically available in two offerings. There is a PaaS Azure SQL. There is a serverless SQL. So yes, databases are also available as serverless today. What happens in serverless database is that the compute is on demand, but the storage is always there. So I'm pretty sure you have an understanding of what is PaaS, but serverless database is really new, right? So what happens in this serverless is something like this. See, so there is a upper limit, and then there is a bottom limit, right over here. So upper limit, imagine 120 GB is your upper limit, bottom limit is 1.25 GB, like that. So, and this is where we are saying performance, and performance is having that relationship with the cost. If there is more GB RAM allocated, you have to pay more. If that less GB RAM, then you have to pay less. So in serverless databases, the compute is on demand. Like if you need more RAM, you pay more in that point in time, but if you don't require it, it goes down, right? And there is one mechanism to auto pause as well. So if things are not running, imagine there is nobody trying to book an order in the nobody's trying to book an you can say nobody's trying to book the Ola cab or Uber cab or any cab in the morning of any taxi aggregator as such. So there is a pause time. See, so there was nothing running for this 1 hour. There was no query running for this 1 hour. So the database will auto pause. It will become zero. Like you're not paying for the database anymore. It became zero, like that, right? Compute is zero over there. And then in the morning, imagine at 4 a.m., somebody again booked the cab. So this is when the database will again get triggered automatically. So this way in which the database is costing us only for what we are consuming, the ping part, and when we are not consuming, we are not paying for it, is called as serverless, right? Serverless databases, on demand compute. This is something which you have to work with when you develop solutions with Azure, PaaS and serverless as such needs to be worked with. Technically, platform as a service is equal to serverless in Azure SQL scenario, but there are some limitations in the maximum number of RAM which you can have in that point in time. Now, okay, so check this out. So, right. So Azure SQL may be one of the output location. This is relational in nature. So you have tables over there. The output locations might be something like Cosmos database as well, which if you have the requirement of going global, then Cosmos database will be there. Now in Cosmos database, as a developer, you have to understand the consistencies which are there. There are 5 consistencies. I'll just show you one picture of it. And the one which we use is called as session consistency. Mostly we end up using session consistency. Not always maybe, but most of the time, like this. So I'll give this link in the chat. So focus on these 5. Understand what do you do with them. So this is when so strong consistency is what relational databases provides, right? They, like if there are multiple databases, they will sync first, then the new commits will reflect. Acknowledgement will come only after the sync has happened to multiple endpoints. So bounded staleness is the one where we have the staleness is there with along with you can say strong consistency. Session consistency is the one which we generally use in Cosmos DB, or which from the developer's point of view, we end up using that. Like that's what we end up doing. Now, some soft point over here. These 2 consistencies are slow. They are pretty slow. From session onwards, Cosmos database becomes 2 times faster than the previous consistency levels. Like minimum 2 times faster performance will be there than the previous ones. Session is the one where your data will be consistent in your own DB session. Go through this statement is very you can say in depth. You can spend some time later on thinking it through. Like what is that my session? Read your own rights. What's the meaning of that? That's what happens in session. Prefix is something which we talk about. You can say is something where the order remains same. This is more like what Twitter uses at the backend, like order remains same. Eventual is like eventual, nothing matters. This we generally don't use in production. It becomes very it's pretty tricky. This one eventual, nothing, there is no order is no guaranteed, so don't use this. Generally we use this, that and this in production. Consistent prefix also makes sense in scenarios. This one, no, not really. If you have any low impact really not important application where there is no order required, you can go for it, but otherwise not really. So this page is very important for you. So everyone who is planning of getting the certification needs to go through and understand what's going on in each and every line over here. Look up in their documentation, look up for what things are there, what details are there, and have a spend some time in Cosmos DB. It's very useful for every company. So some important topics are AKS and Cosmos DB for your interviews. Right. There's a question in the chat saying when going serverless, is there an impact of cold start? So okay, yeah. So what will happen in this serverless SQL? So see, at 4 a.m. when this will start again, right? Here, imagine at 4 a.m. somebody placed the order in the Zomato app or in the food in whichever part of the world where you are joining in. There must be some food delivery applications, Uber Eats type of thing. So at 4 a.m. Here when the query came, there was a start, the database started. This is when cold start will happen. Cold start. If I tell you the exact number, the database will start in 3 to 5 seconds, like that. So database will take 3 to 5 seconds to start. This is cold start in serverless. Literally, it will take 3 to 5 seconds extra. So the query will take more time to run. First only once, then it normally starts. So this is when cold start will happen at that point, like that. Okay, so let's go back to that Cosmos DB. Okay, so this is something where you can say spend some time in Cosmos DB consistency levels and work with it. One more important thing which is there is I'll just see if I can find the example. Okay, so please notice this. Notice this diagram which I'm showing here. There are three services which are pretty confusing as well, but they all are important for the certification. This link is going in the chat as well. Now, what is Event Hub? Event Hub is ingestion layer solution. At the backend, we have Apache Kafka. So what Event Hub does, I'll just give one more minute into it. So you see this Event Hub, which is ingesting the data. At the backend, what this does is it is having Kafka cluster there, literally. So this actually is having Apache Kafka at the backend. So it looks like this. So there are virtual machines running. You don't have to pay for it. They manage it. But see, we have this Apache Kafka. So right over here. So this is Apache Kafka machines at the backend. There is a concept in Apache Kafka called as topic. So this is a topic over here. This is a topic. Topic is that vertically partitioned queue. That's how you can reduce the importance of topic by saying vertically partitioned queue, but technically that's what it does. So it increases the capacity or throughput there. So what is that Event Hub? Event Hub is this purple part. So you see this purple part which we are creating like a box on top of it. So the purple part is Event Hub. And at the backend, we have Apache Kafka. So whenever the publisher, they write the data goes in the topics as such. And then these consumers, they subscribe to the topic and they read from there. So here some partitions will be there. See, this is one partition, another partition, another partition. Let's say another partition, another partition. So data goes in this manner. When the publisher will write in round robin manner, it goes like this. This is data going inside like that. So Event Hub is basically an ingestion layer solution which ingests data, which is having this Apache Kafka, which is at the backend, and big amount of stream is coming in and so on and so forth. And Event Hub is this purple part which is built on top of the Apache Kafka, which we don't have to work with, which is good. Otherwise, it's pretty raw to work with it over here. Now, but what are the other solutions? If we go back to the page I was showing you earlier, there were two other things which were written over there. So there is one thing called as event grid, and this is service bus, right? So event grid is used in reactive programming. So what is the meaning of reactive programming? Let me see if there is any picture given by them. Okay, great. See, so data is coming in from Event Hub. What is this event grid doing? I'll show you. I'll explain one little scenario here. Let me see where I can fit that. Okay, I'll just fit it here. So think it like this. So let's say there was one Azure Web App was there. This is Azure Web App and basically an image gallery application. So this is the customer is uploading their pictures over there. So the customer uploads the picture as such in using this image gallery application. So the application part is there in Azure Web App. Now the backend, right? So let's say there is an upload button here. So you can upload your pictures and then thumbnails will get generated and will be displayed in the application. And if anyone clicks on the thumbnail, then the picture will load back again. So when you create something like this, so I'll just explain one scenario. So let's say the pictures at the backend, where do you store this unstructured data? Object storage. Unstructured data will go in object storage. So object storage is Azure Storage Account containers. So that's where unstructured data will go. This is Azure Storage Account. So you have to know what is the SDK of Azure Storage Account. This is very important from the certifications point of view. How do you work with the blobs? The concept is called as blob binary large object. How do you work with it? So like pictures will get uploaded into this, you can say over here in this image container. And let's say this is image container, right? Now we have to create the thumbnails also. So let's say thumbnails are there, which are supposed to be created. Now, who can create the thumbnails in a serverless manner? Azure function. They are the best to do it. So this is Azure function here. See. So what this Azure function is doing? This Azure function is basically doing the you can say is doing resize of images, creating the thumbnails out of the big images over there. So this is Azure function. So Azure function picks up the data, resize the picture into smaller thumbnails, put the output back over there, and then this is displayed back in the app over there, right? This is the resized pictures over there. But the question is, how will Azure function come to know that the picture arrived? Like there is a picture over there. How will this Azure function come to know? This is where event grid will come into picture. So see, this event grid is one service which is there in Azure behind the scenes between multiple services like storage account to functions, between logic app and functions, and so on and so forth, logic app and storage accounts, and everything. So this yellow part is event grid. So what event grid does, event grid basically is an event passing mechanism, discrete events. It doesn't do streams as such. This yellow thing is Azure event grid. So what we can do over here, right? So what we can do is when the blob will get created, one event will get generated called as blob create event. So blob create event. So whenever the blob create event gets generated, over event grid we can pass that. So this event can be passed over the event grid. This event will not have the data over there. It will have the URI of the blob. So events are very lightweight. We don't have data there. You can put some little bit of payload into it, but you cannot upload huge massive pictures into it, right? Not really. So whenever the blob create event will do, what we will say, event grid, whenever that somebody uploads the HD picture, you tell the function, that function go and read it. So this event grid will pass the trigger like that. It will trigger the function, and that function will go and read the picture. Like it will come to know using the URI which picture was uploaded. Function will go to the storage account, will read the picture, will execute, will resize the picture, and will upload the picture back. So this concept of reactive programming is what event grid will help us in performing, like making people aware, making one service trigger through when something happens in another service. So if you want to perform what I just told you in the screen, I'll give you one tutorial in the chat in 1 second. If you do that one tutorial, your event grid topic will get cleared for your certification. Like you don't have to further think about it. You will have that in your pocket. So what I just told you is what I'm giving it to you, right? So this is their Microsoft documentation. I'm looking for the same example where we are doing the event grid part. So resize the uploaded images. Okay. So this is that image image gallery app, right? So this is your part A of the tutorial. It goes in the chat over here. And then the event grid part is the second part over here. So where we will do the event grid and resize with Azure function. So if anyone wants to get one, you can say hands-on piece on web app, storage, and function, then you do those two tutorials there in the chat, right? Finish them. It will clear your that part of the concept. So at the end of it, it basically does the resize of the pictures like that. There are a few questions in the chat. Let me just have a look at that. Is Event Hub responsible in collecting events from a variety of sources like centralized repository? No, not really. If in the repository, so Event Hub is the one where continuous stream is supposed to come. Like we are imagining that the centralized repository is not something from where Event Hub will be getting the trigger, but something in this scenario. See, so let's think of a food delivery application. So we have this Zomato food delivery application, which is pretty popular in this part of the world. So let's say that is the application over here, and these are the hungry people right now. They are clicking right now, right? So they are placing the order. So order placement, right? They are placing the order. Some of them are canceling the order. Some of them are angry that where is the ETA? My order was not delivered. I want it free of cost, right? Someone is canceling the order. So all the events which are going, whenever they are maybe click events, imagine click events are there. So whatever data is getting generated, we need someone to be, and when we are working on a very large scale, then you really require an ingestion layer solution to be able to ingest that much. So this is where event hub is there, like this. Any centralized repository, explain that scenario further, like what is coming to your mind. Event hub might not be there. So this is, let's say, event hub here. All the orders are getting placed, and this is where we have Azure functions behind it. These red functions are the order placement. So they place the order. So you want the food, they are responsible for placing the order. These purple ones are the order cancellation Azure functions. So they are canceling the orders. So cancel. Let's say the green ones are the ones which are handling the ETA requirements. That's what they're handling. So Event Hub was the broker in middle, like that. One more question is there. What is the impact of cold start if it incurs message loss? Now the good thing is, let's go back to that picture. Okay, so now the good thing is, so let me see if I can find that scalable application. So this was the picture I was showing you earlier, this architecture here. Now, okay, let's think about this one. Imagine this Azure database was serverless over there, right? This one. This was serverless. Cosmos DB can also be serverless, just FYI. That can also be serverless. So imagine they were serverless. Now, what happens if function didn't got the acknowledgement? If the function didn't got the acknowledgement, then it will not delete the message from the queue. So if there is a cold start and it took 5 more seconds for the database to respond, function is not deleting anything. So we are not getting the data loss. It's not like we are not waiting for the response. It's basically an acknowledgement based scenario. If you don't receive the acknowledgement, don't delete the order. Retry. Try after 3 minutes. Try after some XYZ minutes, like that. So retry should be there. Don't delete anything on first thing. Now there is another question in the chat saying which service can be used to store events coming from different sources. I am saying centralized repositories. Now this is where I would just want to ask one little more details over there. When you talk about let's say the events which are coming in, what is the details inside that? Like what is your overall type of scenario? Like what are the things, like where are you getting it from? Is it like somebody did a merge? Somebody deleted something, notification? Is it a DevOps scenario which is coming to mind? Do let me know about that. Okay, so in the meantime, what we'll do is we will just go back to the diagram which we were discussing this thing out. Okay, so one last thing I think we'll be able to talk about, service bus. I'll just cover this service bus. I'll have your questions and I think we'll be on time then. So these 3 things are very important. Cover these 3, right? It's very useful. What is service bus? Let's take this. So service bus is the one where we have 2 type of service buses with us. We have topics and we have queues, right? So let's say this is your application, A application, which is basically the publisher of the data right now, or it is the one which is writing the something you can say messages as such. This is the service bus here. So when you make service bus, this service bus will be having is having a concept called as queue over there. Service bus queues, like that. So what service bus queues will do, right? So let's say these are B applications over here, right? So the A applications are basically writing, B applications are reading from the queue, like this, and they both are scaling on their own. This is also scaling and the A is also scaling, right, over here. Now when this happens, so these are the messages here. Let's use a little less thicker line over there, but this is the messages going like that, right, like this. So these are those XML messages like that. So the service bus queues are used whenever you have not smaller, like your message size is maximum 120, 256 KB and 1 MB. So these are the message sizes in service bus queue. First in, first out is totally supported. FIFO is there like this. And the length of this queue is going to be 80 GB like that. But what happens if if this is not the scenario? You are saying that we actually are not looking for that. Uh, we are looking for the enterprise service bus. Like there is a very popular word in our world called as enterprise service bus. So see, now multiple different applications are there. We have A application, we have B application, we have the green color C application as well. These green colors C, and they all are writing into one central service bus over here. Like this. So something like that. Right. So we have a concept called as service bus topic. See, topic like this over here. Now check this out. So what this service bus topic does, and there are multiple consumers also. See, at the back end you have this D application. This is a D application over here. And then we have this yellow color E is also there. And maybe we have few instances of this one also F over here like that, right? So they all are consuming. Now in this scenario, what practically you will require is you need some sort of partition. So what service bus topic does, it internally creates partition like that. See, these are internal partitions over here. So when somebody is writing the data, they write into one partition, and when the consumers they consume the data, they read from the partition. So service bus topic provides that filtering capability. It provides those partitioning capability. So where are A message going right now? See, all the A message are there in the A partition. See, like this. Where are the B messages going right now? The B messages are going in this B partition over here. Where are the C messages going? C is writing the message in its own partition like this over here. So rest of the concept will remain same. 256 KB message size or 1 MB message size. First in, first out is supported, but in the same partition, not across partition, right? In the same partition. Now, when the subscriber subscribes, the good thing is they can subscribe to one partition. They can also have more than one delivery. So if you can see, the message coming from A is being read by D, E, and F, right? So we can have more than one delivery also. You don't delete when you read, you don't delete. You just you put a read log and then don't delete, let someone else also read. So now different people can subscribe to different messages based on the requirement. So this enterprise service bus, which if this is your requirement, where you want that more than one delivery, where you want multiple applications to be using that central message passing mechanism, this is when service bus topic is used, right? So in your certification, you should know how to do the read write. How should you write into queues, and you should know how to read from the queues. What are the type of locks which are there? What's the default locks as well? How do you extend the lock? Those type of questions will be there. So there was a lab which I was giving you, which I gave you a little some time back. Right over here. So you have to perform this one. So if I just take you to that one, you see this asynchronous message passing here. This is one thing which you have to perform. Like how do you read write from the queues as such? Right over here. Apart from this, if you want further practice, go to MS Learn. You do further practice from there in MS Learn. But this is the lab number 10 is what you should do to be able to understand these the queues, not the other two, but the queues as such. So let me look at the chat window. The question is there. Yeah, use case is related to DevOps. It's mostly about the storing log files. Which service can be used to store it centrally? Okay. Now so check this. Now, if you want to, there are two things which you can use. And so check this. So first thing is Azure storage account. In Azure storage account, we have one concept called as append. So what do we have over here? We have append blobs. So imagine this is the container, like log container. Let's put it like that. Now this is the log file. So this log file goes into append blob. So what will it be looking like? Something like this. There will be a URI. There is going to be a metadata, and then we have the object over there. So this is the object. So this object is actually is having these append, you can say append operation is going on over there. So you can say data is getting appended right now. So the logs are supposed to be kept in storage accounts in the append blob over there. Append blob. Append blob is designed to keep logs as such. Of what? Logs of anything. It can be DevOps logs, it can be activity logs, error logs, any logs can be kept over there. But the problem is, how will I run queries on top of it? Storage account is a storage solution. So we have one service called as log analytics. So what log analytics does, now log analytics can sit on top of the same storage account like that. It sits on the same storage account and create the dashboards for you. So if anything, see, in Azure DevOps, we you actually don't require log analytics, but if I take you to my DevOps portal, see, let me see if I can log into my DevOps portal and show you in a little bit more about there. So this is my DevOps portal, see. So basically, if you create any release pipeline, let me see in which one do I have it. I was showing this to somebody last week, so I have a few projects there. I remember making one release pipeline here, or in this one. Okay, so now if something succeeded or something failed, the monitoring for that can be done from Azure DevOps as well. Or what else can I do? I can have this storage account configured to keep the logs, log analytics on top of it, and the dashboard will be created there. So this is that central location, but the problem is this is not really central. It will be in one part of the world, like East US. Uh, right, like East US, West US, you have to keep it somewhere. So this is one of the best location, cheapest as well, to keep your log files. Storage account with or without log analytics, and see if you can, if you don't even require it, because in Azure DevOps, we basically have the notification options already there. But if you want the analysis on the logs, log analytics is the answer for it. Okay, so guys, we have around 7 minutes left with us. Let's take your questions now. I'll any question which you have, you can ask. Right, so let's use that time for this. And before that, I'll give you the lab. So those who are very interested in what we just discussed, see, if you do this one case study, the probability of you clearing the certification is very high. So this is the landing page, right? This is the landing page where the case study which we discussed is there by Microsoft, right? All the credit goes to Microsoft. Thank them for this. Now the solution is on this page. I'll just give the links directly. This is the solution over here, right over there. You need Azure subscription. Without Azure subscription, you cannot do it. Go for the free trial, right? And the lab is here, like end-to-end deployment. Modern application end-to-end deployment is here. So the lab is there in two parts. There is a part A and part B. So this is part A, and this is part B of the tutorial. So over there. So those who are interested in the certification, go for this. See, so what is going on? You create the container registry, you create databases, event hub is there, data factory is coming, some extra thing is there. Don't be shy to learn something extra. IoT hub, little bit of IoT is there, little bit of ML, little bit of Azure functions, Cosmos database, containers, event hub. Then we have the CQRS is there. Change feed is there, a little bit of Power BI, a little bit of this and that. So modernize your application with data and AI. This is the architecture which you are deploying. This workshop will take you 4 or 5 hours to deploy, but once you do it, it will be you will know what you're doing, right? So this is, I'm giving this link in the chat. Please note it down and use it. Right? It goes in the chat. Note it down. Deploy that. Okay, let's take the questions now. So right, so that logs storage account blobs are the one what we are thinking of. What is equivalent of Windows service in Azure? What do you mean Windows service? What is this? What do you mean by Windows service? Let me know. Uh, Let me know in case of blobs as well. Again, coming from multiple sources. Multiple sources, different append, so different blobs will be here. So imagine this is source number one. So this is coming from one source. Source one. This is another log file, another append blob for the second source. So multiple files for multiple, you can say sources, or every source is writing its own file. That's what I will put it like multiple log files are there in the same location. Like that. This is from source number two. Like this. So not the same file, multiple files. If you mean background running process, then what best is in Azure web jobs as such? Now, literally, there are two things which you can do. First is literally called as Azure Jobs only. We have a concept called as Azure Web Jobs. So what happens in the app service plan, the job is created and that job runs continuously, doing some activity for you. Second thing is, if it is not continuously running, you want some scheduled job or you want event-driven job, then go for Azure Function. So either you use Azure Jobs, literally there's a concept called as Azure Jobs, and secondly, Azure Functions. Those two will be your locations to work with. Right. So like this, I'll give the link in the chat. This is your how to run web jobs. This is the link for it. This is how you do it in Azure. Okay, so we have few minutes with us, guys. Let me know what questions comes to your mind. The case study, note it down. Find me on LinkedIn as well. If you have questions afterwards, also feel free to ask. I may respond in few minutes, a few hours, but I'll definitely respond back sooner or later to you. Right. So let me take you back to that. Find me on this LinkedIn page over here, and you can ask your questions later on as well. Get certified, and if you have questions, feel free to ask.